on time, I guess. Should we start? Okay, good morning. Welcome to the OpenPGP working group at IETF114. I guess we'll get started. We have some remote people, we have local people. I'm Stephen Farrell. This is
Daniel Khan Gilmore.
Okay.
Co-chair.
You're driving the slides. That's the contacty things. This is the note well. I guess you've probably seen that during the week. If you haven't, then note it well. And you didn't add it. We also are all wearing masks today, so please do so. If you're presenting here, you don't have to, but otherwise, please do. Next slide. So this is our agenda. We did a working group last call. Probably it won't be the last one. We have a bunch of issues to talk about that we'd like to get through, and if we can reach some kind of resolution in the room, whether here or virtually, for those issues, that'd be great, and then confirm them on the list later. So that's most of the meeting today, and then talk about next steps for the draft. Then Daniel, who I don't see in the room just yet, has a presentation, and Aaron, I think, is remote. Is that correct?
I think Aaron is remote. Yeah.
Yeah. And
so these presentations are about things that might happen if we can actually get this draft out the door. And so we're hoping that we can get the draft out the door, because we won't be able really to recharter until we do that.
Right. So anybody like to bash the agenda? Looks like not.
No comments on Jabber.
Great. We have Tero's taking minutes, so thanks, Tero. And we can keep an eye on Jabber as chairs. Okay, so like I said, we had a working group last call on draft 6, just really to see where we're at, because we had a design team, as we discussed last time, that was working reasonably hard, I think, in order to try and get the document in shape. If you go to that link, you'll find the working group last call issues all with a label WGLC. And what we'd like to do is, again, go through those here with this highly energetic early morning crowd, and see if we can kind of reach any resolution on those. And if we can, great, and we'll confirm it on the list.
Yeah, and so the hope is that people can speak to these issues as they come up. If you're remote and you're on, in Jabber or Zulip or whatever, and you want someone to say something to the mic, just put it in there and say mic. So I think we'll just get started with issue 132, which is about padding.
So I think what we do is maybe we just flick through the issues just quickly and then go back to the top.
Sounds good.
Some of them might kind of tee somebody up to go and click a link. And,
yep. So the reminders here, this is about whether the padding packet should have all 0 content, random content, or some other scheme. Question about what do we tell implementations to do if they receive AEAD packets and try to decrypt them and get a failure. Issue about whether we include GCM in this draft or not. Question about whether we use HKDF to bind keys to the modes in AEAD. Going to look at what we do with where do the certificate-wide parameters, like algorithm preferences and things, where do they live in an OpenPGP certificate? Are they in the direct key SIGs, as the draft currently says? Whether we continue to disallow the revocation key subpacket for v5 keys, or whether we want to roll that back. Are we okay with the changes to the IANA registry? Right? The IANA registry, the draft currently says that we're moving everything pretty much almost everything from RFC required to specification required, which is a looser requirement to register things in the registries. Do we believe that the text on Argon 2 is clear? Do we have sufficient guidance there? Is there anything that can be cleaned up? And how should we handle problematic keys that we've been seeing in the wild? There's been some reports about some fairly popular keys that don't conform to any of the specifications, including RFC 4880. And do we need to update the text to handle it better? Do we need to modify the spec for v5 keys to not have to worry about this kind of failure in the future? And then the last question, I think, is about how we want to, if we can get through these, we get a new draft out, how do we want to scope the process going forward? Do we want to say, okay, when the new draft is out, if it handles all these things the way the working group agrees, can we just look at the changes going forward, the diffs, so that we can minimize the overall level of churn that happens on the next phase, hopefully the next phase of the working group last call. So that's the queue of issues that we're looking at. I'm going to pop back to the first one, so we can have some time to discuss each one. But hopefully that gives you a flavor of the types of stuff that we're asking for. If you pull the slides from the data tracker, the meeting agenda, you get links there to go to each of the issues, and we'll pull up the issues here as well during the discussion. So heading back to issue 132 about padding, we have this padding packet. And the question for the group is, what should the content of the padding packet be? We've had different people with different perspectives on this. On the list, we've had a couple different variants as this evolved through Git. The status quo is that the padding packet should be full of random octets. And there's a little bit of guidance about where to get the random octets, but there's been discussion on the list about whether we should revert this. And we have a couple different merge requests that actually offer different ways to handle it. So I wonder whether anybody wants to speak to this, either in the chat or here at the mic. If nobody's been in the queue yet, to get in the queue, if you're in the room, please use the Meet Echo Lite thing and click that raise hand.
So Quinn is remote, except the mic is a bit low. So
okay, sorry about that. Can you hear me? Is this better, Quinn? I see PHB in the queue for padding. He's here local.
Well, if you can, I think the simplest way of disposing of it on any item is if you can find a security reason. If you put zeros in, well, you've got some known plain text, and that gives an attacker some leverage that they otherwise wouldn't have. If you put random in, then you have created a covert channel that can and will be exploited. So I don't think that. So a rigid construction based on something that is to do with either that is to do with something generated from the key, but through a different KDF or whatever, seems to be the best solution, because then you don't give chosen known plain text, and you don't give a covert channel.
Thanks, Phil. Does anybody else want to speak to some of the trade-offs there?
Sorry, I apologize. I believe this was brought up on the mailing list as well, and people were a bit worried about the resources it would take to do this new HKDF or whatever to get this random data.
yeah, and I think for this issue, I think we had 2 merge requests, right?
Yeah.
Do you want to do the screen share? Or
sure. Let me see if I can figure out how to do that again. I will unshare that. I will screen share this.
So I think for this one, we had 2 merge requests. One basically was saying, here's this deterministic construction. And I think the other one says, I forget what the other one ended up saying last.
One of them says it must be all zeros. And the other one says it should be so 204 is all zeros. 203 is deterministic along those lines.
Yeah, I was meaning deterministic, not a hard.
Yeah.
Yeah. But then there's the 203, there are 2 variants of deterministic, one of which was always the same deterministic data, but I think that goes back to Phil, your known plain text argument.
Yeah, it's weaker, but you only need to change.
To the mic, please, yeah. We have remote people.
You only need to change the data really slightly to take away the, to take away the leverage.
Yeah.
And I think the other point that came up in this discussion was with the deterministic one, you could ask implementations to try and verify that it was done correctly or not bother. So that was the other kind of flavor of this.
Right, so the receiving implementation needs to know what to do. And I guess we have this question of what would a receiving implementation do when receiving one of these things that's supposed to be deterministic but isn't? Like, should it reject the packet stream? What kind of brittleness are we willing to incorporate in order to defend against this particular covert channel?
So I guess our idea here was that we'd let people talk to these issues till they're happy, and then probably try and get a sense of the participants' kind of opinions via a poll. So I guess I should try and figure out how the polling tool works. I think for this one, probably the easiest thing to ask is, should we have 0? I think the random padding is, nobody's that keen on random, right? Which is what the current draft says.
I mean, I think obviously some people wouldn't have made it into the current draft.
But just from the discussion, I mean, if somebody wants to speak to the keeping the thing as is, that'll be good.
But maybe the question that you raise is a better one to put as a poll, right?
Sorry, Justice says he's keen on random. Okay.
Or maybe the question that you pointed out is a better one to add to the poll, which would be, I see Aaron in the queue. Aaron, do you want to speak?
Yeah, I also think that like there are many ways on OpenPGP to put in some side channel, like to put in some covered data. Just adding a packet that is an unknown version or an experimental, and therefore adding random, I don't think is that much of adding. Like, it's not adding that much to the covered channel in OpenPGP.
So it seems like one question is, do we want receiving implementations to reject padding packets that are considered to be malformed, right? Because that actually would govern are we making a requirement about what goes in it or not? Right? We can make recommendations about what to put in it, but there is this underlying question of, if we make a recommendation and it's not followed, are we going to expect the receiving side to reject it? Is that a reasonable question, or is that queuing up too many polls?
Yeah, I think that's So perhaps I just start a poll with, should we leave it as the draft has it now, as random? Random is recommended, I think.
Random is currently recommended, and there's a separate discussion about what, this kind of randomness is probably the least important randomness of all of the kinds of random. There's a section about how do you generate randomness in OpenPGP, and it calls this out as a distinct flavor from like key generation randomness.
Okay, so I think what I'll do,
Daniel's in the queue here.
Justice is also, Justice was saying that the design team members often expressed opinions in the tracker. He feels like repeating them doesn't add anything new. What should we do? Please do repeat opinions, Justice, and send audio or text as you prefer. Because I think we'd like to have the discussion so that it's on the record for everyone, and we can try and resolve it. Daniel?
Yeah, so I don't actually have an issue with random data in the padding packet. The only issue I have with the current text is that it suggests that the random data protects against higher level compression disguising the, let's say, padding, or sorry, negating the padding. So in my opinion, it doesn't, because the compression will compress the non-random padding anyway, and will reveal information about the length it has. So I'm fine with leaving it random, but just removing that text. But yeah.
Okay, so how about that for a question?
Yeah.
Okay, so what I'm going to do is try one of these polls, because some of these issues are things where people have opinions but don't necessarily feel hugely strongly. So I'm going to ask, do we keep the draft 06 random padding scheme? So I'll start the session. If you think we should keep it, please click the raise hand button. If you think we should change it, then please click the do not raise hand button. We have 36 people in the room, so 9 hands being raised or not. 8 and 1. Okay, it's not changing. So just for the record there, for the audio record there, we got 8 hands raised and 1 hand not raised, which I think indicates that we probably should go back to confirm on the list that it seems like keeping the current scheme is what people want. Okay?
Okay.
Okay, so BKG is going to...
I'm going to put that in the notes.
In the issue.
Yeah, let me just copy the specific poll, 181. So let's move on to the next issue here.
How do I get rid of that?
I think I dismissed it. No,
No, it's up there.
Okay, so the next issue here.
Oh, it's still up there.
Oh wow, this switching between the slides and the. Oh, I see. There's open the voting.
Reopen the voting?
Here we go. I got it. There we go.
Okay.
I found the button.
That's done. Okay, great. So that's our. Okay. So this one, I think. Well,
go for it.
Yeah, actually. I think I actually understand this one. So that's helpful. So this one here, when we're using AED algorithms and you decrypt, the issue is how to handle that. We have some chunking so that these decrypt failures don't necessarily apply to an overall message. And currently, I think the text in a few places says that if you get an AEA decryption error, there's a should fail kind of statements. And I think the suggestion for this issue was to change those to must fail instead of should. So again, we'd like to get a sense of, I don't think we have a merge request for this one, or do we?
We do.
Okay, so there's a merge request for this one. If you click through the links, you'll find the suggested change. So,
do we want to offer? I just realized there was one person who was sort of odd person out whose hand was do not keep. And do we want to, on the last poll, do we want to ask that person if they want to?
Okay.
But your opinion was that you would be okay with keeping it if we remove the justification? Got it. Okay.
Okay, that was Diana Huygens for the record. Yeah, that was a good thought. Okay, so for this one, there was some discussion. I think mostly it was kind of in the affirmative, like saying that change would be a good one, I think. So would anybody like to speak to this, whether remotely or locally? If not, I think we'll just do another poll, say make the change or don't make the change. We'll just give people a second. What's the merge request number for that one? Do you know?
Yeah, that. Oh, it's actually not linked. Sorry.
Hmm?
It's actually not linked. I'll pull it up.
Okay.
206.
Okay.
And I can put that on the screen if that would help people. Should I do that?
Well, I think this one's kind of straightforward enough. You can just do a poll. I suspect I know the answer to it.
Okay.
Okay, so I'll start a poll saying, should we make this change to change the kind of should statements about AEA decryption failures into must statements? If you think we should make the change, please click the raise hand button. If you think we should not, please click the other one. That's looking pretty clear.
Nobody wants to speak to it. Everybody seems to be in agreement.
Okay, so that's 15 people raised their hands. 0 people did not raise their hands. So I guess that's relatively clear. sure if I like this button. How did we get rid of the thing?
You go back to this.
Yeah.
Oh, whoops, sorry.
And then do that?
Yeah, reopen the voting window and then the red button.
Ah, okay, end session. Very good. Okay. Great. Thank you. Next one?
Yeah. Sorry, we're at the presentation here.
It's still displaying there, yeah.
There we go.
Okay.
Okay. GCM.
So this one had a bunch of discussion. I think good points are raised on both for inclusion and non-inclusion. I won't really try and summarize it, but the issue here is whether the current draft includes GCM as one of the AEAD methods that's defined. The issue is that somebody's basically saying we should not include GCM because we have another AEAD mechanism with OCB.
We actually have two. We have OCB and EAX.
Sorry, we have two others, yeah. So, and again, there are arguments for and against inclusion of GCM. And I think another salient point is that currently with the specification required IANA rules, if we do not include GCM, somebody else can come along and add it next week, as soon as we're done. So it seems like the opinions are kind of all over the place, but let's give people a chance to speak to, should we include GCM in this specification now or not?
And yes, I know that we talked about this on the mailing list. I know that we talked about some of the tracker. There's Quinn, yeah?
Quinn, go ahead.
I think you have to enable your own audio, Quinn. Let's see.
Phil, if you're in the queue, probably jump in.
If you've got OCB, it's a much stronger construction. Now, yes, somebody can add it to the IANA, add GCM to the IANA registry, but if I'm going to implement PGP, I'm going to implement the algorithms in the draft, and I'm not going to expect to be able to send mail in a scheme that is not in the draft. So not putting it, sorry, if GCM is not in the RFC, it will have a material impact on adoption. And it will encourage people to use OCB, which is a stronger construct, which we all should be using.
So thanks for the reminder, for the clarification. OCB in the draft is flagged as must implement, yes, and EAX is not flagged as must implement. And GCM is also flagged as is not mandatory to implement. Yeah, I hear what you're saying about the presence in the draft, but there is a notable distinction between the modes, and there is an advertising mechanism where you can indicate what AEAD algorithms you support with what other ciphers. So you won't accidentally encrypt using GCM to somebody who doesn't support it, and everybody has to support OCB anyway. So that's the baseline part of the interop that the current draft tries to do, whether that's right or not, or whether that's useful. So, but it sounds to me like you're speaking against including GCM.
Well, I think you can make a case. I mean, GCM's a stream cipher. Why turn a block cipher into a stream cipher?
Okay, Quinn? Yeah, Quinn, do you want to go ahead?
Quinn, you have to turn on your own audio here. I'm not sure if that's not working for you, or if you want to put what you're saying in the chat, we can relay it to the mic as well. Enabling your audio is it's a button in the it's the microphone button in the upper left.
Sometimes you have to restart your IETF because sometimes the whole browser, because the first time you turn it on, you don't give it the permission.
I got it. I'm sorry.
Yes.
Are you hearing me now?
Yes, we are. Thank you.
Thank you. I'm sorry about that. So right now, GCM is not mandatory to implement or mandatory to. However, if there are people who want to use GCM, then I don't want to tell them. So make them to be non-compliant to that they need to really that we should do. That is something that we should do. GCM, but it's still good in some cases. So that's why I think it's okay to make GCM is not a mandatory one, but
Thank you, Quinn. Do you want to talk to what you think the reasons are people might want to use it?
Great, thanks, Ken. So yeah, you're clearly asking for essentially the status quo with the draft, which is to keep it as an option. Paul?
Paul Ouders, speaking as an individual. I don't think it matters very much where GCM is defined, whether it's in this RFC or in another one. The people that are going to use it are most likely the people that need to be FIPS compliant, and they have no other choice at this point. So those will need to implement these things anyway, whether they're in a separate document or in this RFC. So I don't think it matters where it is, but as the people who want FIPS have no other choice at the moment, they will do this anyway. So I don't think it's much of an issue where it is defined. So, but I would personally recommend just doing it with the group, so that we don't get somebody else by their own writing specification for a GSM.
Thanks, Paul.
Hi, Jonathan Hamill, Canadian Center for Cybersecurity. So I'm in favor of including GCM. While we don't have requirements for using FIPS validation, it is our guidance because it does provide implementation validation. It's not just a policy, it provides a security benefit that the implementations can actually be tested by an independent lab. And that's why I would like to see it included.
Daniel Huygens with OpenPGP.js maintainer hat on. I'll acknowledge that our requirements are somewhat peculiar, but the reason we want to use GCM is because it's in web crypto. It's the only AAD mode in the web crypto API at the moment, which is natively implemented in browsers and gives much better performance. So yeah, we'll most likely implement it whether it's included or not. Indeed, not for FIPS compliance reasons, but yeah, for for performance reasons. And we can either do that under a private algorithm ID, or in a separate document, or in this document. But yeah, most likely we'll be implementing it anyway.
Ori Steele from Transmute. I agree with everything he just said. I probably would get support for it if they were to implement it anyway, but I think for the reasons stated, regarding FIPS and the expectation that I think users will have, that there would be at least one sort of FIPS algorithm that would be available, I think it should be included.
So Ben Kadek from Remote.
Ben Kadek. So I feel pretty similarly to Paul in that this is going to happen, and having the working group do it sort of lets us retain a little bit of control. I don't have a particularly strong preference at all, but I have a slight preference that the working group would specify GCM, but in a separate document. But if we keep it in this document, I can certainly live with that. I know that there are definitely going to be some cases where people need to use GCM because of the FIPS requirements. And so having us use our expertise to make sure it gets well specified and there aren't any gotchas with it seems preferred to having some random person write it up in a hurry when they need it. But again, whether that's in this document or a separate document in the working group, I don't really care.
Great, thanks, Ben. And the queue seems to have drained on this one. Okay, so how about I'll do a poll saying keep, where the question is keep GCM as an option as per .6.
Yeah, and so if you raise your hand, you're arguing to keep it in the draft. And if your hand is down, you're arguing that it should not be in the draft, whether that means it should not ever come in, which is going to be difficult to do, or whether the working group should work on it or something else. If you feel that way, you can say, do not raise hand.
So I figured this one would actually go all one way, or would be 50-50, but this is the better option. Okay, we seem to have stabilized with 14 hands raised asking to keep GCM as an option as per .6, 15 hands raised now, and no hands not raised. So I think that indicates preference that, again, we'll confirm on the list.
Yep, and I'm noting that in issue 135 as well.
Great, thank you.
So yeah, no, we can ask the 0 people if they want to stand up and explain what.
They're already there.
Okay. So so issue 136 is a little bit trickier. So the way that we have AEAD specified in draft 06 uses HKDF as a key derivation function, which pulls in a chunk of metadata, including the choice of mode, so that your key can't accidentally be reused across modes if someone is tampering with the construction that you have. There's some concern that key reuse across different modes could lead to some kinds of problems. I believe there may be other arguments for why to use the HKDF as well, but the issue raised on the list was HKDF is an unnecessary additional construction to include here, and maybe it would be simpler if we were to remove it. This is, again, it's issue 136. So I'm wondering whether folks would be up for speaking to this. Again, I know that we have had discussion on the list about it. I know we've had discussion in the issue tracker about it. But we would like to have that discussion here in the room if we can, anyway. So now's a good time to state your opinions and preferences here.
Yeah, so the most specific issue that I know of why this was brought up was there was a paper where GCM ciphertexts could be converted into for example, ASCFB ciphertexts. And then if you have a decryption oracle for CFB, which has happened in the wild, then you also have a decryption oracle for GCM, which basically means that the security of the GCM mode then gets reduced to the security of CFB, which is bad. So, I mean, in general, I think not being able to convert keys and ciphertext between different modes is good. But yeah, so that was the most specific issue that I know of. So if we're keeping GCM, then I think we should definitely keep this as well.
Thank you, Daniel. Justus, I see you in the queue.
So I want to stress that this is not only about GCM. This is about preventing downgrade or cross-grade attacks. And OpenPGP has suffered from a downgrade attack in the past. So this is just a good belts and suspenders approach, and I'm for keeping it.
While you're there, Justus, do you want to mention the other reason I think that you've advocated for?
Yes, so the other kind of feature we snuck in there is that we have a salt in the CypD version 2 packet. And the idea is that if you get an encrypted message and you don't have the sender's certificate, that you can reuse the asymmetric key material and just change the salt to derive a new message, a new per message key from the session key.
So that makes it like a reply. It makes reply functionality when the keys are not available a possibility.
Yes, that's correct.
Anybody else want to speak to what they feel about the HKDF in this context?
I guess nobody else is, but I think the argument against essentially was that this is a change, and change before, change is not necessarily always good. That's I think the argument was against it.
But I don't see anybody else in the queue. Should we do a poll on this as well?
So I was going to say keep HKDF as per draft 6. That's the question. Okay. Does
that seem okay? Folks in the room okay with that being the poll text? Keep HKDF as per draft 06. This is HKDF for AEAD. I mean, there are other places where HKDF shows up. Just to
binding modes. Okay, so that's the poll will be keep HKDF for binding modes as per draft 6, and you can raise your hand if you think we should, and do not raise your hand if we should kind of revert that change.
And again, do not raise your hand means actively clicking do not raise hand. You can't just sit there.
It is always confusing, isn't it?
Well, you can.
Exactly.
We seem to be attracting one more opinion every time we do this. That's great. Oh, 2 more. Okay, so that seems stable and pretty clear. We get 17 hands raised to keep HKDF for binding as per draft 6, and 0 hands not raised. And we'll close that poll and go to the next one.
All right, and I'm putting that in the issue tracker as well. Thanks, folks. Issue 137, questions about where certificate-wide parameters live. So certificate-wide parameters meaning things like your algorithm preferences, things like the expiration lifetime of your primary key, which is by default the expiration of your entire certificate. The current draft 06 says those parameters for V5 keys specifically, those things should live in subpackets of a direct key signature on the primary key. In V4, the tradition has been that those things could live either in a direct key signature on the primary key or in the user ID the self-signatures over user ID subpackets. So the current draft says for v5 keys, don't look for those things in the user ID self-sigs. Just look in the direct key. This makes it a little bit more predictable, I think was the rationale coming from the design team, and a little bit simpler to consider what's happening. But it is a change from v4, so it makes v5 certificates look slightly different. It does not actually, the draft does not change v4 certificates. If you're going to implement v4 and v5, you will have to have the complexity for dealing with v4 certificates anyway. So the question is, do we want to allow these parameters? Oh, and then I guess the other wrinkle to this is there's some amount of concern that by putting these parameters in the primary, in a direct key signature on the primary key, it might facilitate certificates that have no user ID, because now you've got the parameters, they're all there, and you can just go ahead and leave the user IDs out. And as from several generations of the draft, the user ID has been moved from must-have 1 to 0 or more user IDs. So there's some concern that this provides some pressure against user IDs, or pressure towards user ID list certificates. So, those are the concerns that are sort of bundled into this question. I wonder whether anybody wants to speak for either for the text that's currently in the draft for v5 certificates or against it. I see Ben in the queue.
So I'm not actually speaking for or against at the moment, but asking a question in that in the v4 setup where you can have preferences at the per UID level, do we have any reason to believe that someone was using this for some complicated setup where they have, you know, a multi-UID key, but they have like different implementations on their mail reading setups for the mailboxes that receive those different UIDs, and somehow they wanted to express divergent preferences based on the different implementations that could process things specific to that UID, as opposed to, you know, I have this key, it's in multiple locations, or maybe it's only in one location, and I just can handle what the key has. Like, do we think people use that flexibility in that way?
I mean, it is explicitly contemplated in RFC 4880 that this is, you know, it says like, if you look this key up by user ID Alice, then use the preferences from user that are bound to user ID Alice. But if you look it up by Bob, then use it for user, then use the preferences found on Bob's self-sig. I have not heard anyone say that they are using it like for themselves. I don't know that anybody's done a survey of keys to see whether some, you know, how many of them have different preferences per user ID. And I also don't know whether anyone's done any testing to see whether implementations that are sending actually respect that. Because how do you know whether you're accessing the key via Alice or Bob? Maybe you've done some binding that says when I send to Alice, use this fingerprint or something like that. And then from the OpenPGP implementation, it just sees you passing the fingerprint and doesn't know that you're looking for it in terms of Alice. So I don't know that we have that much data about whether it's been used. There certainly has been nobody stepping up to say, if you rip this out, I'm going to be sad because I have 2 user IDs that I expect to have a divergent divergent parameters, and I want to see those things present. So I don't think we have much data, but we definitely don't have anybody standing up publicly and saying, I'm using this. That has not, you know, nobody has mentioned that on the list.
Okay, I guess that puts me slightly leaning towards keeping it just in the direct key sig. And
so I think
I can imagine uses for UID-less keys as well, but that's not quite the question being asked.
Yeah, so I think on the list in the discussion, Werner was kind of opposed to this change because he wanted there always to be a user ID. Is that correct?
Right, but we could mandate a user ID without this change also. But
Okay.
that would mean one additional signature in a certificate, because you'd have to have the direct key sig for the parameters and then the user ID binding sig.
Okay.
Oren?
So, I mean, I think the question about this is like, what are you thinking about for, you know, V7 or V8? Because it sort of signals a direction you're planning on taking. Like you mentioned, you know, if you have to support V4 and V5, you're going to have to account for this anyway. But in future states where you're supporting V8 and V7 after, you know, years of this change, this could be a lot simpler. And I am also in favor of not requiring user IDs. So that's my thoughts.
Thanks.
Yeah, I was also gonna say regarding user ID less keys, it can also be seen as an advantage that this allows that. There are some use cases for not having a user ID, for example, if it doesn't have anything to do with email, or if, let's say, you don't want to publish the user ID in some contexts on WKD or something like that, or if you have a catch-all address where you want to serve some key for many different email addresses and you don't know in advance which ones you want to serve it for. So, and you don't want to keep the private key on the server, so you can't generate a user ID on the fly, then I think it's useful to be able to serve a user ID less key. So I think that this change, allowing that, is a good thing.
Thanks, Daniel. Eustace, I think you're up.
So I also like user ID less certificates, but I want to say to Ben's question, if someone has such a use case, they're better off having two distinct certificates. And the complexity that comes with having the preferences on user ID bindings is huge. And the behavior of implementations is basically unpredictable. And it also complicates stuff like simply adding a user ID, because adding a user ID now potentially changes the preferences of the certificate. So you better find the current binding that you think is the most recent one or so, and use that as a template. And the fact that simply a simple operation like adding a user ID potentially changes the behavior of your certificate or the preferences is insane.
Okay, I think we seem to have drained the queue on this. So I'll ask the poll again, and this time it's essentially as was on the slide. It's certificate-wide parameters live in a direct key sig for v5, and should we keep that as per draft 6? So I'll start the session. If you think we should keep it, please raise your hand. If you think we should revert that change, please do not raise your hand.
We've lost some people from last time.
Yeah, it's a more complicated question. Being on the fence on is probably more reasonable on this one, isn't it? So we have, so far we seems to stabilize that 8 hands raised and 0 hands not raised, which is an indication, but I guess, again, we'll confirm on the list. And if somebody does turn up with some use case, as Ben kind of indicated, then we might have to revisit. But for now, we have an opinion. That's good.
Okay.
Thank
Noting
you.
that in the issue tracker as well. Okay, so issue 138. In RFC 4880, we have a subpacket that indicates that the key holder is willing to accept revocations from a third party. This is the revocation key subpacket. It contains a fingerprint of the authorized revoker. In the draft, we say that this subpacket is invalid for a v5 certificate. And we describe an alternate mechanism for doing a sort of delegated revocation, which is just to make a revocation signature and send it encrypted to the person that you're willing to have be able to revoke your key. That mechanism is available, obviously, to anyone with v4 keys as well. It's not a novel mechanism, but it's the first time that's been described explicitly in the draft. The question here is whether we want to keep this revocation subpacket, continue forbidding this revocation key subpacket for v5 keys. Some of the reasons arguing for the removal are that given that it's just a fingerprint, you might not even have a copy of the key, and you might see a revocation and not know whether it belongs or not. So there's an issue, there's a logistical issue. And secondly, the implementation support for the revocation key subpacket may not be as universal and robust. So relying on it seems a little bit dangerous compared to relying on an actual revocation signature. So I think those are, but the concern here, of course, is that it's still valid for v4. So your implementation that does v4 and v5 will have to do both. And some people say that this is actually a concretely useful thing to have, and they want to have it available for v5 and are not comfortable with the escrowed keys. So hopefully people can ask clarifying questions if you got them, or speak in favor of the removal for v5, or speak in opposition to it. Now's a good chance. If I mangled that explanation of the problem, I hope people will correct me as well. Ben?
Hi, Ben Kaduk. So I can imagine a scenario where the escrowed revocation signature has like a setup that is more risky than the revocation key subpacket. And that would be if the receiver of the escrow has some system that like does automatic processing on messages it receives and would like automatically decrypt it to put it into some other internal store, and maybe that other internal store also automatically updates some things. So you could get into a scenario where the mere fact that this revocation signature exists causes it to get uploaded prematurely when it wasn't intended to be. It was just like, I have some data, it's associated to this key, let me publish that type thing. And like this seems pretty unlikely to me, and I'm not super concerned about it, but it is an additional risk of this proposed mechanism that I don't know if we talked about before. I don't remember.
Thanks. I think that's a valid point there. The original removal here was accompanied by a proposal for a replacement for the revocation key subpacket that actually included the revoking primary key, the key material of the delegated revoker, and that was seen as either too complicated or out of charter or too distracting, which is why we're in this removal phase. That's why this is the proposal is where it is here. That would solve the logistical problem. And it also potentially solves the, I guess, a linkage problem. Eustace, you want to speak to it?
So I'm in favor of removing that because it just acknowledges the fact that virtually no implementation supports designated revokers. And I think that's due to the fact that it requires non-local reasoning about multiple certificates.
Can you talk to how when you say, you're maintaining the interop test suite, can you speak to the support? I mean, you said it's that few implementations support it. Can you describe like the test that?
I don't think we have a test for that, sadly. We should have one. But we didn't implement it because it was very complicated. So I doubt many implementations out there support it. Maybe Daniel can shine some light on his implementations. Thank you.
Yeah, so we also don't support it. Personally, I'm not opposed to the idea of including the revocation key in the subpacket directly. That would make it much easier to check the revocation signature if there is one, at the cost of slightly increased key size, but I think that's reasonable. So, I mean, yeah, we can argue about whether it's in charter, but I think if we're removing it here, which I think is reasonable, then I also think that adding a replacement is reasonable. but I'm also fine with just removing it and without a replacement other than having a revocation certificate, which is already a mechanism that exists and is used, and we already support it also in v4. So I think that's reasonable also.
Ben Kadek again. Thanks everybody for the extra discussion. I think that has sort of solidified my thinking that in favor of removing the revocation key subpacket for the v5 keys. That's just like acknowledging the deployed reality that you can't rely on it to work. Seems like something that's really appropriate for us to do in the biz document. And so I would like to see it that way. I'm okay doing that even if we don't have a replacement mechanism specifically. I would also be okay, as Daniel is, with having this mechanism for like the actual full revocation key in the key, because like the size issue is only an issue if you actually use it. And so if you don't use it, you're not affected. But I'm also okay just removing this and not providing a replacement right away.
Thanks, Ben. I think the queue may be drained on this one.
Looks like it. Shall we do a poll?
Okay, so same as before, it's the question of the slide. So the revocation key subpacket is disallowed for v5 keys in draft 6. Should we keep that? If you think we should keep it as draft 6, please raise your hand. If you think we should not, then please do not raise your hands. And that seems to have stabilized. As then it moves. Okay, so that seems to have stabilized at 10 hands are raised to keep the scheme in draft 6 and 0 hands are not raised. So that's good input. So the next one is kind of a slightly less, slightly easier one to get your head around. So this is IANA. So in 4880, there's a whole bunch of IANA considerations and registries that require IETF consensus for change. And the suggestion in most cases, not absolutely everywhere, but in most cases, the draft 6 basically changes those to specification required. And for those of you who are not IANA nerds, the impact there is we're moving from a situation where you have to get a document through the IETF process to do things like add support for another algorithm. And we're moving to a scenario where somebody can just say, oh, I've written a paper and I published it, and can essentially ask an expert to be designated by the IESG should the algorithm get a code point in the IANA tables. So that's where the draft says we're going. That's where we're coming from.
And the two exceptions there that remain RFC required are packet type and packet version. So for the places where the versions show up are still require an RFC, and minting a new packet type is also.
So I think it requires IETF consensus.
IETF consensus, sorry, yeah.
Because an independent stream RFC doesn't have that. So yeah, there's a couple of exceptions, but the basic movement is towards allowing specification required, which is kind of loosening up things. A lot of other groups have done this over the years, but it's worth checking. Because, for example, it means that a vanity cipher code point could end up there. National algorithms can end up there, which may be good or bad. So the question is, do people have opinions? And can we confirm that that change is kind of a good idea?
We should also note that this will require having a designated expert.
There's already one registry that requires a designated expert who does not exist.
Okay, so this puts even more weight on that non-existent role.
Yeah, this is the document. So yes, actually, designated expert is needed, and I think it would be very useful to keep the instructions of the designated expert. What kind of specifications are? We probably want to have some kind of stable reference, published, some other standards organization paper, not just some web page somewhere. So usually the designated experts have quite are quite free to actually, interpret the instructions they are given. So we don't have to written very specific instructions that say that, okay, designate the expert requires a stable reference, and he decides what is stable enough for his point of view.
So just while you're there, do you have an example of some specification that does that well that you can remember?
No.
Okay.
I think most of the RFCs are, for those RFCs that I'm, for example, designate the expert, I think they actually just say that they're expert. There's actually no specification required, but I have always, as an expert, required to have a specification before I actually go forward and say, okay, you have to have a 3GPP, for example, specification is okay. Some web page I will say, okay, I don't know if I would want to allocate numbers based on that.
Ben Kadek, I actually got up to make basically the same point that Tara made about we should have some guidance to the experts. But I do have an example of a case that I think does this pretty well. I'm actually the sort of ghost editor for the COSI drafts that are in Auth48 at the moment, because Jim is no longer here to do the Auth48 himself. And so we have some text in there about the expert is designated an expert as a reason because we should trust their expertise and give them leeway, but also guidance about the proposed mechanisms or algorithms need to actually be appropriate for the requirements of the registry that we're trying to use. Like if it's supposed to be a signature algorithm, it has to actually provide the signature functionality. And I think there's also some guidance there that it needs to meet the community requirements for security. So like if somebody wanted to propose a null security, a null signature algorithm, essentially, that doesn't meet the requirements of the community, if there's also some pointers to like CFRG is a good resource in there. And in addition to sort of answering the question that you asked of Taro, I wanted to also say that in general, I do support this. I think in other areas like TLS, and I think IPsec is actually in the process of doing this as well, opening up the registries to make it a lower burden is good for the ecosystem. I guess I also wanted to mention a counterexample in the sense of the expert is not given very much leeway. In, I believe, the quick registries, the policy is basically a shall issue policy, and the expert is there to like apply some back pressure if somebody is asking for a lot of code points or something like that, or if they're asking for a specific code point that might be problematic. But the guidance to the expert is basically, you've got to approve this.
Can you send to the list a pointer to the specific draft that you think has good text, the COSI draft that you mentioned?
Sure, I can do that.
Or in the chat, yeah. Just so we have a note that we can use to update it.
Yeah, I'll drop it in the chat for sure, and I will try to remember to send an email as well.
Okay, thank you, Ben.
So I'm editor maintainer of a registry that was recently opened up in this way. And I think it is a positive thing that's happening. Like you mentioned, it's sort of trend in the space, but the guidance to those maintainers is critical. And if you don't give good guidance to them, you open huge political cans of worms for them, and they're likely to resign. So you ought to just make sure you give them good guidance. And I also think it's important to support the sort of mental shift that goes along with this kind of process as a community. Because if it's happening, it should be supported by the community. So have a designated expert, give them good, solid advice, and then cheer for them while they handle the onslaught of registrations.
Can you point to guidance that you have found useful in that position?
Sure, I can. I'll send it to the list. But I may have to get connected offline.
Yeah, that would be very helpful. Thank you. Did you actually experience an onslaught?
Yes, but for a registry that I don't want to bring up here to cause any challenges.
Okay.
Great. And Roman has posted, and Ben have posted some more about that COSI stuff in the chat. So I think we've drained the queue on this one. So I'll ask the question like this. So if you're happy with these changes, but we should also give guidance to the designated expert, then please raise your hand. If you'd rather we don't make that change, then please do not raise your hand. And that one seems to have stabilized with 11 hands raised for keeping that kind of, keeping these changes, but giving some guidance to the DE, and 0 hands not raised. Thank you. Okay. All right. So I created this issue yesterday just in response to, there was some list discussion about Argon 2. And I think the issue essentially is the text sufficiently clear? So if people have opinions or have been watching this thread on the mailing list, then please do speak to it. I'm not sure we'll do a poll on this one. I think it's a case of we'll probably just have to go and check. But
yeah, and one of the ways that we can determine quantitatively if it is clear is whether we have functioning interop as well. I mean, Justus as the sorry to keep poking at you as the maintainer of the interop test suite, but can you report back on how things, like whether Argon 2 has been tested? Is this something that might be in the lineup?
So sadly, we don't have a test for Argon 2 yet, but we have 2 interoperating implementations, one of which I believe is GNU-PG. Maybe Nibe can talk about that.
GNU-PG my branch support Argon 2 because the libgcrypt 1.10 already have Argon 2 support.
okay, so I think the situation is that we seem to have. I think Niba said that it's supported and then Justus is saying that it interoperates. So that seems to say that the text is not horrible. But I think so. I don't think this is one we'd have a poll on. I think this is one where we should go back and check essentially, because Argon 2 does have a bunch of parameters. Clearly, one person on the list at least has found that confusing or something. So I think the resolution of this one is we just need to go back and check and see, is there something that needs improving.
Yeah. Anybody else want to speak to Argon 2 here?
And again, I'd encourage, if people can just have a look at that text and see, do they think it's clear? That would help, I think. Yeah.
Sorry, Pavel. So I thought there was maybe an issue that some people did not want Argon 2. Are we not talking about that, or?
Yeah. So that was, I think the person who found the text unclear also was arguing somewhat against it, but that seems to be a fairly niche opinion as far as I can see. But again, if people want to suggest removing Argon 2, then go ahead and do that. But I didn't see a lot of people suggesting that, or and it. I mean, to be honest, Argon 2 seems to be a much better way of doing kind of string to key. So
it's also, I mean, it's the winner of the password hashing competition, so that was why it was selected.
Yeah, okay, so I think the resolution for that one is again, if people want to talk to it now, that's fine, but the resolution there doesn't need a poll, and is we need to look at that text just to convince ourselves it's clear and fix if not.
Yeah, and if a third implementation could become interoperable, or if we could get proof on the test suite that that these things are capable of being interoperable, then that would be useful too. Great, useful evidence for clarity. All right. Getting through this, folks. This is good. So
second last one, I think.
Yeah, we're on the second to last. So thanks everybody for bearing with. So we've had some reports on the list recently about OpenPGP certificates that are fairly widespread and do not follow either RFC 4880 or the current BIS draft, the crypto refresh, because of some changes in some of the metadata that they have. We have two potential things that we could do as a community of specifiers. One thing is we could adjust the text in the revision to explain a little bit better about how this metadata should be prepared and to describe what an implementation should do if it discovers that the metadata has been ill-prepared. So that's just like documentation cleanup. And another thing, which we actually have a merge request for, is to strip out those pieces of metadata that are apparently ambiguous from v5 keys so that they simply wouldn't be present in those structures, so you couldn't make those mistakes. Might still be worth adding documentation about how to deal with v4 that have those pieces of metadata. But so this is the GitHub key. Apparently GitHub's key itself has a weird behavior. And we've also seen some keys generated by OpenPGP-PHP that have similar but subtly different misbehaviors around this metadata. So what do we want to do about these keys? Do we want to try to change the draft? Do we want to remove the stuff from v5? Do we want to give clear guidance about whether to ignore if these fields are not set?
So just, I mean, you described it as metadata. Is it not just a checksum or something?
It's a checksum, and is there one other piece, or is it just the checksum that we're talking about here?
But it's not a free-form metadata.
It's not free-form
label
metadata.
here. It's
no,
just,
there's a checksum that indicates what has been signed.
So I think it's a checksum. So okay, so
it's supposed to be a checksum, but some implementations include things that are not the checksum.
Oh, okay.
Yeah, Eustace, you're in the queue.
So I'm aware of two issues. First, there is the hash digest prefix in the signature packet, and the question that came up initially was, what should implementations do if the 16-bit prefix is wrong? And that, I think, happens with the PHP implementation. And the GitHub key and GitHub PHP implementation has a different problem where they produce malformed multi-precision integers.
So everybody's exhausted with all this. Yeah.
We're close, folks. We're close.
So for the first issue, I have one fairly orthogonal argument for removing it entirely, which is that if you have a crypto API which lets you hash and sign in one operation, then it's nice to be able to use that without needing to get the intermediate hash, which web crypto does. So again, it's fairly specific, but I think that's useful. And also if implementations are not checking it anyway, well, some implementations are not, then it's perhaps not very useful to put it there anyway. We do check it, in fact. So I am also not opposed to just having some text that says you should check it or something. But
and by check it, you mean reject the signature if it doesn't match without bothering with the cryptographic outcome?
Yes.
So would you want, do you want that to say you must check it? Like you must reject the signature if it doesn't match? One of the problems right now is that we have Heisensigs, right? Where some implementations accept them and some don't.
So again, the only real reason I see for two reasons I see for not checking it is, one, you have such an API where you can hash and verify in one step, or, well, there are keys out there in the wild that are broken, so you ignore the bytes for that reason. So, I mean, both of those would, to me, speak for either removing it or saying that you should or must check it and reject the signature if it's invalid. Yeah, personally, I would slightly prefer just removing it entirely, but yeah, if we keep it, then I think we should check it.
Okay. Ori?
Again, agree with everything he just said. Becoming a bit of a theme. Yeah, if it's there, it should be checked. If it doesn't match, it should be rejected. I'm in favor of removing it. I'm not sure exactly the impact on the keys in the wild based on that statement, but sometimes you make things that they're broken, you have to make new ones.
Well, I think if we were going to remove it, it would only be applied to V5 keys, right?
Right, we wouldn't remove it from V4. We can't remove it from V4. Yeah. Eustace?
So my theory that this is or was once an optimization, right? You could skip the heavy lifting of doing the asymmetric operation when you can determine from the hash prefix that the signature didn't check out. But I want to highlight that we have a bit of a heuristic based on that, where we use it to reorder certificates that are somehow mangled in transport by a key server. So, and here we can use the hash digest prefix to see if we can find the correct location for a misplaced signature, even if we don't have the full context, like the issuing key. So I kind of prefer to keep it for that kind of reordering to improve the robustness. But I would be okay with making the check mandatory.
So if we're going to do a poll, it seems like we've got at least two separate issues here, and we've spoken mainly to the first one. So maybe we want to try to do a poll to resolve this first one, but about the checksum in the signatures. I'm trying to think how we want to pull this. Right. So one of them is, I guess, should we remove the checksum from V5? And we've heard Eustace argue against it. And Daniel, I think you were mildly for removing it. And then the other question is, should we make it mandatory to, retrospectively as well, for V4 signatures as well, and then V5 if we keep it, should we make it mandatory to reject the signature if it doesn't, if the checksum doesn't match?
Okay, and yeah, okay, so two polls. One is, do we want to remove it from V5? And second poll is, should we make it mandatory to
reject a signature?
Knowing that implementations out there don't currently do that.
That some implementations don't do that, right?
Okay. All right, yes, we'll ask the question. What's the main thing we're removing?
The signature checksum. Is that fair? Signature checksum? Anybody want to propose a different name?
The question I'm going to ask is, should we remove the signature checksum from V5 signatures?
Yep.
Okay, so should we remove this problematic metadata field from V5 signatures? If you think we should, please raise your hand. If you think we should not, please do not raise your hand.
Okay. So I'm seeing two people who are in the do not raise hand, and I wonder whether anybody wants to speak to those, to why they would prefer to not remove it.
And just for the record there, we had 7 people expressing opinion. 5 raised their hands for removal, 2 did not raise their hands.
I assume that Aaron, you want to speak?
Okay, so I think that it provides debug information too. So like at times it can be very useful to have these 2 bytes, even if we don't check it on a regular basis, to understand whether implementation is broken or not. Or whether the data that has been signed is different. Like at times you can understand where's the bug.
Okay. So the 3 arguments for keeping it that I've heard are, 1, it allows you to reject signatures faster. 2, it allows you this debugging argument. It gives you some extra hints about where the problem might be in the emitting implementation. And then 3, Eustace's point about being able to reorder certificates more efficiently without doing the heavy lifting of the crypto piece. I see Eustace out of the queue now.
Okay, so yeah,
I mean, that's input. It's a bit. That's a kind of rough.
Yep.
Consensus, if consensus. So we're verifying the list and see where we go. And then the second poll we wanted was,
should we mandate that implementations must reject a signature that has the wrong checksum in it?
okay, so I think what I've typed is, should we state that implementations must reject signatures V4 or V5 with incorrect signature checksums? Okay. So you can see the question. And we know that there are implementations that won't do it. Okay, so for this one we have currently 9 hands raised saying that we should add that must, and 1 do not raise hand. So if the person who did not raise their hand would like to speak to that, please do so.
Aaron?
Yeah, I mean, same as before. It's the thing is, depends what's the use of it. I would definitely be in favor of a should. A must might be at times too hard, especially if you know that there are some implementations out there that are broken.
So, okay.
Yeah, I mean,
yep.
That's fine. We'll take it to the list.
Okay.
And then I guess so. Then what we haven't discussed yet is this malformed MPIs in certificates like the GitHub certificate, right? So the Mpi specification is very clear, but not necessarily always followed. Apparently, it's not as clear as it could be. It says that it indicates length by bits for some reason, and in this situation, we have certificates that are, it's supposed to indicate the largest bit that is set to 1. But in this situation, we're looking at certificates which contain MPIs or make signatures that contain MPIs. Is it signatures or certificates that we're only seeing this in? Anybody? Aaron, are you still in the queue from last time? Sorry. Oh. We're seeing this mostly in, oh, there you go, Eustace.
So I've seen it in the signature that GitHub creates for merge signatures, but also in the binding signature of the GitHub certificate itself.
So it's in the signature. Okay, so the question is, what do we do if the MPI in the signature is malformed in that it indicates it has a larger, it's basically counting bits by full byte, I believe. So it seems like we ought to have some guidance so that we can point an implementation to what they should do about it. It seems to me, I mean, in terms of just leaving it at nothing doesn't seem very useful to me. I don't know what sort of guidance people would want. One is that you could tell people to reject a signature. Another one is you could tell people to clean up the signature if the MPI has this particular alternate form. Or?
So I'm not sure exactly of the internals, but unless there's a way to warn in a softer but very annoying way regarding this, I think the signature should be rejected.
That would mean rejecting all of the signatures that GitHub makes on merge commits, yeah?
So, I mean, is there a security? I don't think there's a security issue here, though, is there? I mean, there were some odd length keys that Bleikenbecker attacks work slightly better on. If you had like a 1025-bit key or something, or 2049.
But I don't think that has a relevance in this.
Yeah, exactly. So,
yeah.
so I
Ben, you're up, or
Ben, go ahead.
Yeah, I think Daniel beat me to actually getting in the queue, but I had unmuted. So my understanding here is that for these problematic signatures, you can modify the ciphertext so as to, or will modify the metadata really so as to make it a valid signature. And I believe that would not really be something that can constitute an attack if you can just fix it yourself.
I think that's right. What is your conclusion from that, though, Ben? Are you saying that we should give people guidance that they should fix it?
Probably. I mean, it doesn't really seem like it's not like a cryptographic failure on the signer's fault. It's just a implementation failure to read the spec properly. And because the cryptography still checks out, I think the practical and like in favor of better interoperability would be to just fix it and maybe complain loudly if you have the ability to do that. But saying you should reject this just feels like breakage for the sake of breakage.
I think if we want to say that implementations should or must reject it, we could do that for v5 signatures and keys. But for v4, I also don't think we can. For full disclosure, very old versions of OpenPGP.js also used to produce malformed MPIs in some cases, particularly if there were leading 0 bytes. So it was a slightly different issue than this one, but still, I don't think we can be super strict for MPIs in v4 signatures, but for v5 we could if we want to.
Justus, you're up.
So my concern is that if you have a system that is composed out of multiple components and they use different implementations and they behave differently, you may be able to confuse the system as a whole, where one of the implementations will say it's a valid signature and the other one may think it's an invalid signature. And that may be able to create problems.
Tiro?
So I think, the issue that some GitHub or somebody generates signatures that are wrong is not really issue in that case, because I think they can fix their, signature generation faster than we can get implementations to check this. signatures.
Well, they have old signatures that are there.
Yes, that the old signatures are there. That's true. But actually, as I said, I don't know if there's actually any way of like somebody was saying, it would be really nice to get warning, and that's actually one of the things that Ben was saying, that we could actually fix it in before we actually give it. So we could actually have an implementation actually reacting the signature and then checking that if it's actually, it's a signature that is, if we fix it, it actually works. That would actually allow, user interface or programs to actually way of, having a separate method of, or the other thing is to that just react it on for version 5. But actually, the most important thing, of course, would be to get, the people who are doing this to fix them. So unless you start reacting them, I don't think GitHub is going to be, is it still generating those signatures?
I believe it is, but I haven't tested it today.
So I think because they don't see any reason to change it unless somebody actually starts breaking things. And I think we should, it would be better to have, not to have this kind of corner cases, because they usually have, as was pointed out, if you have an implementation that actually checks this, another one that doesn't, and it might be happening very low level in the crypto library. Your crypto library might be saying, oh, no, this is not an MP, valid MP int, because it doesn't have a first bit, 1. And then you might not be able to have to react it in that might cause, this kind of issues that some, one part that was supposed to do something based on this and does it because it's valid signature, other one doesn't because it's invalid signature.
So I'll share some sort of similar practical experience from handling ECDSA signatures for the SEC-P26K1 curve. There's upper and lower S representations, and the Bitcoin and Ethereum communities have decided to normalize to lower S, yet OpenSSL and other libraries produce both upper and lower S. Some implementations will fail to verify the signature, some won't. And in practice, the way I've defended our source from this is to manually lower the signature to lower S before emitting anything, outside of our library. So for the libraries that are handling this, they could decide, every time I see this thing that's a problem, I'm going to fix it for myself. But everyone has to decide to do that, and it's a mess in the code, So I think for 5, it should error, and for 4, you should leave it as is.
Justus?
So the idea came up to just issue a warning. I don't believe that there are libraries out there that have a suitable interface to create warnings. And even if they did, it's not clear what an application should do with the warning. If they display that to the user, I don't think that would help, actually. Also, I'm not sure if we should make an exception for v4. It was wrong for v4 before. That's nothing new.
Let me add one additional wrinkle here, which is I believe OpenPGP allows you to make signatures over signatures. And that means that fixing a signature by twiddling the bits in the MPI header will change the bytewise representation of the signature, which means that will in turn invalidate any outer signature that is made over a signature itself. So for example, if we're talking about MPIs generally, twiddling the bits in the MPI of, say, a public key will actually change the fingerprint of a certificate, which is not insignificant. So if we're doing guidance, we need to think about the guidance about MPIs for signatures, maybe distinctly from the guidance for MPIs in public key material. Otherwise, you have 2 separate fingerprints for the same public key. It's a mess.
Yeah, I think if you're fixing this, it's at a very low level in your code.
Right.
Okay. I don't know if we're ready to kind of do a poll on this. I think maybe could we get a volunteer to produce a merge request? I don't think we have one right now.
No, that would be great, right? Actually,
yeah. So would somebody be willing to try and write a merge request to
propose something that seems reasonable to you? Because
based on this discussion?
Yeah, we've had a lot of different perspectives coming in here, and it's hard to see what the right outcome is. Maybe if we had, I see a hand raised. Can I?
Fantastic. Thank you, Daniel. Okay, so I think that's probably where we should move on from that one. I think the very last one, and then we have some presentations for amusement. So I think we've made good progress. We confirm it on the list. The question to people is, we've got draft 6. Let's imagine that draft 7 or 8 or something includes the resolution of all these issues that we have so far. We'll probably want to do another working group last call at some point. Do we want to raise the bar for that, for future kind of work, to basically ask people to only really be looking at the diffs from, let's say, 7 to 8 or 8 to 9? You know, if somebody finds some new facts or comes with some new information, then we'd have to look at things. But should we raise the bar to try and get ourselves done by essentially encouraging people to only look at the diffs beyond, you know, from 7 to 8 or whatever draft actually resolves these issues? Paul.
Paul Wouters, AD. Speaking to a former AD, Stefan, can you do that as a process? I think not, right? Like if you do worker group last call, it goes over the entire document. So,
yeah, but we can, it's an expectation matter. So and yes, it has been done in HTTP BIS, for example.
But if someone does it anyway against your expectation, what are you going to do with that information? Like, are you going to then say actively ignore it on the list? Because
no,
you
deal with it. But it's a question of, you know, if the working group, and I think so, HTTP did this a few times. They basically agreed that they wanted to get stuff out, so they were asking people to look at the diffs. If people look at other things, you've got to deal with it. But I think we can do it if people want to do it. So nobody's in the queue. That may indicate a lack of enthusiasm.
Or it may indicate fatigue after an hour and a half of
slogging
through these things.
Okay, so for this one, I'll bring it up on the mailing list.
Ben's in the queue.
Oh, okay. Thank you, Ben.
Sorry, you called so passionately for people to be in the queue, Ben Kedek. So yeah, I think it's probably worthwhile doing this. And to sort of Paul's question, you could certainly frame this as saying we did a working group last call in this previous version, and we believe, you know, after whatever evidence, that it has consensus. And so bear in mind as you're reviewing that, you know, we have a presumption that this other stuff already has consensus, and so focus your review on these changes would be most fruitful. But as Stephen says, of course, if somebody does come up with a real issue, even on text that has been reviewed already, you do need to handle it. You don't just ignore it.
Okay, so yeah, we're all tired of issues. So what I'll do is I'll raise this on the list when we think we've got a next draft out, and we'll see how people think about it then. So there's no poll for this one. I think that was our last slide.
Yep. So we have so we are not chartered to do work beyond this crypto refresh, but there has been interest expressed on the mailing list and here at IETF 114 about potential for rechartering. We are not going to discuss rechartering right now, but we have 2 proposed presentations about some material that might feed into a rechartering. So if folks have other things that they want to raise about the crypto refresh beyond the issues that we've just gone through, now is a good time to raise them. If you don't, then we want to give the remainder of the time to some discussion about these potential issues that would come up after a recharter. Does that sound right?
Yeah. And I guess what we neglected to say is that we'll obviously take the minutes to the list of these resolution stuff and issues, and then we'll depend on our kind editor to make changes and get a draft 7.
Yep.
We'll talk to Paul about when that's possible. So. And I guess nobody in queue? If nobody's in queue, then I guess Daniel is up.
Yes, thank you, Stephen. And yeah, so just to reiterate, this presentation is explicitly out of scope for the crypto refresh. It's more so meant to provide some ideas and maybe some motivation to get this crypto refresh out the door and get to working on new stuff. Of course, that only works if there's actually interest in these ideas. Otherwise, well, I hope there will be. So yeah, next slide, please. So first, for an overview of the status quo in OpenPGP, we have asymmetric keys, which are typically long-lived and managed in a key ring. And we have symmetric keys, which are either session keys or derived from a passphrase or a password that you can encrypt messages and keys with. Next slide, please. And asymmetric cryptography in general is, at least the algorithms that we have in OpenPGP currently, are more vulnerable to quantum computers and are also slower, whereas symmetric cryptography typically is less vulnerable, at least if you use sufficiently large keys, and is also faster, or at least the performance for a given security level is better. Next slide, please. So this leads us to the conclusion that there is sort of a missing middle or a missing type of keys if you want to encrypt stuff with a symmetric key if you don't need asymmetric cryptography. So it would be really nice if you could store a symmetric key in a long-term key ring to use to symmetrically encrypt stuff, but maybe also to symmetrically sign stuff using an HMAC or a CMAC if it's just for yourself or local storage. Next slide, please. So yeah, for the use cases of symmetric encryption that we see, that we have in mind for this, is, yeah, so if you have some symmetric file encryption, or you have some file storage that you want to store files symmetrically encrypted for backup or long-term storage, or on a USB stick or whatever. Or if you want to symmetrically re-encrypt the messages, the emails that you got, for example, for long-term archival, you can decrypt them asymmetrically as they come in, encrypt them symmetrically and store them like that, so that yeah, it's smaller, it's faster, and then if you want to retrieve them in the future, decryption will be faster, and in general will be more secure again as against quantum computers. And in this way, it lets us prepare, let's say, for quantum computers, even if they aren't here yet, but at least then we don't have a giant body of RSA encrypted and ECDH encrypted messages lying around, let's say. And then finally, for drafts, before you're sending an email, it would be nice to be able to symmetrically encrypt them. Again, it's faster. You're not sending it yet, so you don't need asymmetric encryption. You can store them on a server if you want to continue editing the draft somewhere else later. And yeah, next slide, please. And then for the use cases of symmetric signatures or MACs, so if you have a symmetric key that you want to store, and that's only for symmetric usage, then you might also want symmetric key binding signatures just to be able to store information about the key, expiry and everything else that we have. Similarly, you might want to store some signature about a file to make sure that it's authentic and hasn't been tampered with, or if you put it on a USB stick and retrieve it later to check that it's still the same file, might be useful for that. Or if you want to store the signature verification result, let's say you get an email, you check using RSA or ECDSA or EDDSA that the email was signed, and you don't want to have to do that every time that you retrieve the email later from archival. So you store the verification result using a symmetric signature, let's say. Next slide, please. So our proposed solution to this is admittedly a little bit hacky. Our idea is to define two new public key algorithm IDs, namely AAD and HMAC. So the reason we are proposing that is because the semantics of public key cryptography in OpenPGP today match much more closely what we want to achieve, in the sense that you encrypt a message with some key that you refer to by a fingerprint, for example, or you sign a message with a key. Whereas for symmetric cryptography in OpenPGP today, you encrypt the message with a password and you derive a key from that. There's no way to refer to a long-term key, let's say. So in that sense, it's much more convenient to be able to stick a public key algorithm ID in a key packet, a signature packet, and a public key encrypted session key packet. Despite, of course, the name not matching what it actually is. So there's one idea. Of course, it's not necessary to do so, but to fix the mismatch, we could retcon the name of, well, the algorithm registry, perhaps, and also maybe the public key encrypted session key packet and the symmetric key encrypted session key packet, which, by the way, the latter, I would argue, is already misnamed because it's more password encrypted session key packet. But okay, so we could rename those perhaps to persistent key encrypted session key packet, or and derived key encrypted session key packet, or personal key and shared key, or something like that. Or we could leave it as this and just live with the hackiness of having symmetric algorithms in the public key algorithm registry. Yeah. Next slide, please.
So I've just thought of some guidance for us to give the designated expert.
Not to do this, or what?
Asymmetric keys should be asymmetric.
Fair enough. So, despite that guidance, we do have experimental implementations in a fork and a branch of OpenPGP.js and GoCrypto, respectively. So this is not meant to be used already, but yeah, just to see how it would work. And we have a draft specification. Again, it's still very much up for debate. Another way to do this would be to define a private public key algorithm. We could use algorithms 100 and 101, which is what actually the experimental implementations do. Or, I mean, I think there would be some value in having this be interoperable. If you want to export your archive of email and import it somewhere else, it's useful if other implementations also support it. So then I would somewhat argue for actually defining an algorithm ID. But you might also argue this solution is way too hacky. We should define new packets with better names for this or something like that. Next slide, please. So yeah, the questions for the working group I have is, first of all, is there interest in this? If so, should we add it to the next charter? And if so, do you think this is a reasonable solution or is this way too hacky? And if you think it's a reasonable solution, please do read the draft and let me know if you have any comments. Thank you.
Thanks, Aya.
And are there any questions, of course?
Yeah, so we have a little time.
Okay.
As a quick question. You mentioned signature verifications. Is that in the draft? Or is that it's in there?
Yes, so there is an algorithm ID for HMAC in the draft now, so you can symmetrically sign using HMAC and then also verify the symmetric signatures using the long-term symmetric key.
Right. So, but I thought you mentioned some idea about storing a persistent verification result.
Right. So
but that's not in the draft. Or?
No, there is no specific mechanism for how to encode that or how to store that at the moment.
Because there is a thing going through lamps from Stefan Santos on about signature verification tokens. That might be good looking at if that's actually interesting.
Okay. Thank you.
Okay. So thank you.
Yeah.
Aaron.
So I can give you control of the slides, Aaron.
Okay, so if I click it forward.
No, you should see the.
Okay, yeah.
Great.
Okay, so today I wanted to present how like an idea we've had to do automatically email forwarding. And this means that with the user being offline, we can forward their email to another OpenPGP user with clearly setting up this protocol beforehand. So this is the outline. It's going to be, I'm going to try to keep it short, especially the mathematical part of it, but yeah. So this is the concept of automatic email forwarding. I think we're all familiar with it. And the problem is often that OpenPGP, in order to do that, you just got to share the key. So you got to take your key and send it to the forwardee so that they can read the ciphertext. In this case, instead, what we do is we delegate the authority of transforming a ciphertext to a mail server, to a proxy that can directly deliver a transformed ciphertext to Charles that will be able to read the email while we're on holidays or something like that. So the idea is basically the following. Alice is the original sender, does not know the fact that there's a forwarding ongoing, and she basically sends an encrypted OpenPGP message to Bob, as all the papers we've read so far. And but Bob has basically created a proxy transformation parameter, this KBC, uploaded it to the proxy, and the proxy can use this transformation parameter to transform the ciphertext into a message for Charles. Charles must have received as well DC, the private key, that will use then to decrypt the message coming from the proxy. Here is what happens behind the boxes. So mathematically speaking, the concept is actually not too complicated, because in ECDH, it's just a multiplication onto the elliptic curve field. We have prepared a proof in a paper that this is actually a safe operation, and any attacker that is not Charles colluding with the proxy is pretty much left with an ECDH instance. In the interest of time, I will skip the exact details of the math if you can find it in the paper. The schema is composable, so this means that in fact you can basically set up a chain of forwardings. So you can set up multiple forwardings for Bob, and Daniel could also set up his own forwarding to Frank. So the idea is the fact that this chain can be built theoretically infinitely long. Now, The problem with the OpenPGP implementation is the fact that we can't use vanilla OpenPGP because CHARS requires a modification in their implementation. So it is transparent onto the sender side that is probably the most important, because we can't go and get someone else to update their OpenPGP implementation. But it is not transparent onto CHARS implementation. So when you accept to be a forwardee, you need to accept a special key that says you are receiving forwarded email. And this is the reason because this happens is because there's in the key derivation function, there is a binding to Bob's key. And if we do not know Bob's fingerprint, we cannot decrypt this key. We cannot decrypt this message. We cannot obtain the same shared secret. Diving a little bit into the OpenPGP changes that I think are more relevant, what basically happens is the fact that into this parameter in the hash, we do not have we do have the fingerprint of Bob's key. In order to there are two ways to work this around that we thought of, and they are to add the fingerprint to the PK ESK. So basically to say, hey, this message was originally intended for this fingerprint, but this makes the message distinguishable. So someone observing the message on the wire might be able to tell that this message is a forwarded message. And second, this basically says for each message, you got to acknowledge that that message is forwarded. While instead, if you add this information to the forwardee key, this becomes a little bit more once you accept a forwarding key and add it to your keyring, your implementation should tell you this key is actually Bob's key, and you will receive only email encrypted to Bob that it has been forwarded for you. Since this key, as we've seen before, is generated, here we can see it's generated from Bob, so Bob knows the secret of this key. It is better, and you're receiving this key from someone else. We thought it would be better to have a key that you know the fact that it can only be used for forwarded messages, and no one can send you message encrypted directly to this key. So these are the reasons that has pushed us to put it into the forwarded key, this extra information. Now, as I said before, the threat model is basically that we assume that Bob is always honest and never leaks the public key or the private key, because this would clearly break any OpenPGP protocol. But as soon as the server and the forwardee party cooperate, they can recompute Bob's private key with a simple operation. This key, since is an OpenPGP key, it's meant only for encryption, and in the RFC should be specified that this key must be used only for, but it should only have the encryption flag so that it cannot be used for authentications or signing. And yeah, so basically this is it, and we've wrote this paper that you can find under this address. You can also download it from the slides, and we wrote this paper that allows you to set up this forwarding scheme. And I would like to ask the community whether there is an interest into standardizing this kind of procedure that was already briefly discussed at the OpenPGP Summit. And whether, I mean, if there's interest, I guess I volunteer to write an RFC for this. In particular, we've used curve 25519 in our analysis because it's a pretty solid curve and well regarded in the community.
Great, thanks, Aaron. I think we're pretty much out of time. And so as and when we get to the point of rechartering, I think it's these kind of ideas would be up for discussion, so I guess.
Yep, sounds right. Thank you for the presentation, Aaron.
Thank you. And with that, thanks for all your patience with us this morning as we worked through those issues. I think it was fairly productive. We'll take it to the list. And I think we're set for this meeting.
Yep. Thank you, everyone.
Thanks.
Yes.